Hello, my name is Matt, and today we're going to be playing Vortex by Zondebok. This is a Sudoku that has been around for about 15 days and has just over 300 solvers. So with that, let's start the puzzle. This one looks like a fun one. I'm excited to start by reading the rules, I guess. Normal Sudoku rules apply. So this is a Sudoku, and we're going to put the digits 1 through 9 in every row, column, and box. Adjacent digits along a green line must have a difference of at least 5. So these are German whisper lines. I've done a lot of videos with these in them. And I skipped a rule along the way, which is that digits along an arrow sum to the digit in the arrow's circle. So I guess this is an arrow. Yeah, but for explanation, these three numbers, they're going to be like, 1, 2, and 3 or something like that. And then we would put maybe a 6 here so that the sum of these three digits, the sum of the digits along the arrow is what goes in the circle. But now that we've read the rules, let's start on the puzzle. And the first thing I see has to do with these green lines. When you have green German whisper lines, where digits along the line need to be separated by at least 5, you can't put a 5 on the line anywhere. The reason for this is that there's no number that you could put beside it. We would need to put something like a 0 so that the digits are separated by at least 5 units. But since we know that a 5 goes in this box somewhere, and since we know that the 5 doesn't go on the green line anywhere, that means that this 5 needs to go here. You are going to be a 5. Cool. And now, do we know anything about the 5? Can we do something more with this? I guess a 5 can't go in this column, which would mean in this region there's only a couple of spots for 5. Here, 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 and here. I guess you can't be a 5. Okay, so maybe we could do this. So where does a 5 need to go in this box? I'm not sure yet, but we know that it can't go on the lines. And I think we know that it can't go in this circle. Maybe it can go in this circle if this was like a 1, 1, 2, 1, 1, 3, something like that. I guess maybe this can't be a 5. How do we get a 5? 2. I was thinking about the fact that, well, if you have a straight arrow, which we don't, then the digits would need to be unique along them. And that would mean that the minimum sum is 1 plus 2 plus 3. That's going to be 6. Here, we don't need unique digits because the line goes into different boxes. So maybe we could have a 1 here and a 1 here. But the thing that would prevent that is this one. Regardless, I don't actually think that's the place to start. Let's see if we can figure out something else now that we know where 1, 5 goes. I guess the digits, let's see, these two digits are on a green line, which means that they're separated by at least 5 units. So that means this number needs to be at least 5. This could be a 1, and this would be a 6, maybe. They'd be separated by 5 units. But for that to happen, this would need to be at least a 5, 6, 7, 8, or 9. Something like that. And then what that would mean is that this needs to be a low number. What do I mean by low numbers? Well, if we have a green line, these green lines aren't allowed to have 5s on them anywhere. And when that creates is this sort of oscillating pattern of high and low digits. First, we would maybe start with a number that is less than 5. This is a low number, like 1, 2, 3, and 4. But then what would this need to be paired with? It would need to be paired with a number that is at least 5 units from 2. We need to go from 2 to something at least 5 units from it. This would take us up to a high number like 6, 7, 8, or 9. So we know on the green lines, we're going to have this pattern of oscillating high and low numbers. So I'm going to put colors in, and this is just going to make everything even more dense on the screen. If one of these yellows turns out to be a low number, then all of the yellows need to turn out to be low numbers. If one of the yellows is going to be 1, 2, 3, or 4, then all of them need to be 1, 2, 3, or 4. And I bet we could actually determine that now. Is it possible for the yellows to be high numbers, numbers that are greater than 5? It's not, because the minimum of these two would sum, like if it's 6 and 6, this would sum to 12. There'd be no number here. What that means is that all of these yellow cells that I just highlighted, they're definitely low cells. They're going to be the numbers 1, 2, 3, and 4. In this region, we're actually going to use one copy of those numbers in each cell because they need to be unique. So maybe this is a 2, then a 1, then a 3, then a 4, something like that. But this is just going to be a generic low number. It could be 1, 2, 3, or 4, and it's not going to have conflicts with the other ones. Now I wonder where the 4 needs to go on this green line, because a 4 can't go in a corner. If this was a 4, for example, then we would need digits that are separated from it by 5 units. The only thing that's possible is 2 9s, and this would cause a conflict. So I think what that means is that on this green line, the 4 can't go on any of the corners. It can't go here, here, here. U must be our 4. And now we know that this is a 9. And now none of U can be 4s. Just like I marked the fact that the low numbers are the yellow cells, I can also mark the fact that the high numbers are going to be the red cells. Here we have 6, 7, 8 left for these 3. And by the way, I think at this point I could probably remove the colors, but that's probably fine. Now we know that these digits, these 3 digits, are going to sum to the digit here. The problem is that this is a 4, and this is a pretty big number, although it's a low number. If this was 1 and 2, which are the smallest 2 numbers that could possibly go here, then this would result in 7. If this was 1 and 3, this would result in 8. But it's not possible for you to be a 9 because of this 9. You're only allowed to be 7 or 8. And what that means is that one of these 2 digits needs to be a 1, and the other one's allowed to be a 2 or a 3. So maybe I could just put them in like this. Sometimes I use the corner pencil marks for this, but we're going to need a 1, 2, and a 1 in one of these cells. The other one is either going to be a 2 or a 3, and then that's going to identify whether this is a 7 or an 8. Cool. That was maybe helpful. Now we know that this is a low number, and this is a green line. So I can repeat the thing that I did above, and I can make these our low number cells, which are going to be the yellow cells. I can make these the high number cells, which are going to be the red cells. And it would look something like this. Now we wouldn't really have any problems if this was a 4, by the way. I guess we would, because the 4 sees it. But up here we were able to use the corners to determine where the 4 went. If this was a 4, forget this one, then we could have like a 9 and a 9 here. That would be allowed. But I guess you're not allowed to be a 4, so you can only be 1, 2, or 3. Now we know where another one of these 1, 2s, and 3s go in this column. You must be a 6, 7, 8, or 9. And the same is true for this one. Maybe I'll make this one yellow too, just so we have a little bit of consistency. Cool. I noticed one more thing, which is that along the green lines, we have this pattern of low and high numbers that oscillates. We need to figure out which one goes where. If you think about this green line, we know that this number needs to be lower than this number because this number appears in the sum to get this number. That means that this one needs to be a high digit, this needs to be red, and this one needs to be yellow. The reason why that's interesting is that there are only 4 low numbers and there are 4 high numbers, and then there's this central 5, which we don't have a color for. But in this row, we know where all of the low numbers go. And the thing that is interesting about that is that we know where we know that these 3 low numbers are 1, 2, and 3. This has to be the remaining low number, which is 4. Now there's only one number that can pair with it on a green line, that's 9, and it needs to be separated by this digit, which is 5. So you must be 5. You're not going to have a color, but all of you now need to be high numbers. You're all red cells. And you're definitely 6, 7, 8, and 9. And you definitely contain a 9 because we know that a 9 doesn't go here. So in this row, the 9 goes here. In this row, the 9 is going to go up here someplace. So one of these cells needs to be a 9. Nice. But I bet I could actually follow this more. We kind of got sidetracked. I don't even know where the sidetracking started. I guess you're going to be 1, 2, or 3 also, so you need to be yellow. And you're going to be red because you're going to be a high number. But we got a little bit sidetracked. I bet we could do more with these in some way. Where is a 3 allowed to go? If a 3 went here, then we would need 2 digits that are separated from it by at least 5. That would make both of these 8. That would cause a problem. You're not allowed to be a 3, and neither are you for the same reason. The only one that's allowed to be a 3 is this one. You're a 3, and now you need to be our 8. And now neither of you are allowed to be a 3. Neither of you 3 are allowed to be a 3, and neither of you 2 are allowed to be an 8. Now, it's not possible for a 6 to go here. This would force both of these to be a 1. You need to be a 7 so that you can be 1 and 2, but that would force you to be a 6, which forces you to be a 1, and now you're a 2. And now you're a 1. And if you're a 1, then you're that other missing number we talked about. You're either a 2 or a 3, but you're a low number. So now we know all of this. But if this is a 6, then this needs to be a 1. Excuse me. This needs to be a 1 by the green line rule. So we've done this. All right, so you're not allowed to be a 3. We know that. You must be a 1 or a 2. Wonder where the other 1 or 2 goes. We'll figure that out a little bit later. Something that's interesting is that we're going to need a 5 in this region, but that 5 can't go in this row. It also can't go in this row. That means the 5 needs to go up here. But what would happen if the 5 went here is we would need a number here. So 5 plus 2 is 7. You're not allowed to be a 1. You would need to be a 2, and then you would need to be a 9. That's a possibility. We could have 5, 2, 9. I think that works. We can't put a 5 on the green line. The only other spot other than this one for a 5 is this one. That seems allowed. Is there any reason why this can't be a 5? If this was a 5, this could be a 2. These would add to 9. This would be a 9. This would then be 6, 7, 8, and 9. Excuse me, 6, 7. Oh, there needs to be a 9 here someplace. You guys, you're high numbers, but you can't be an 8. You must be 6, 7, and 9 in some way. Now the 8 is going to go someplace else. But you could still be 2 and 5, and then you would be a 9. And I think that would all work out. Regardless, I think you two need to be low numbers. And I think you need to be low numbers because if we have a 6, then we would need a 1 so that the 7 works, and we can't have a 1 here. So you two both must be low numbers. You must be 1, 2, 3, and 4. But you're not allowed to be 1, so you can only be 2, 3, and 4, and this one isn't allowed to be a 4. So you can only be 2 and 3, and you can only be 2, 3, and 4. That's what's allowed there. Two and 4 would make 6, and then we could have a 3, which would make this a 9, or we could have a 2, which would make this an 8. You are only allowed to be the numbers 8 and 9. And now you must be a high cell, which is red. Really working our way around, by the way. We're kind of going around this vortex, which is, I guess, this pattern made by the arrows. Almost it's made by the arrows and the lines, actually. But we're working around the vortex. You are both 1s. You could be a 2. You could actually be a 2. And what that would do is that would make this a 4. But that 4 would have a conflict, so you're not allowed to be a 2. You also can't be a 3, and you also can't be a 4 because of this 3 and this 4. Can you be a 5? If you were a 5, then we would get 7, and that 7 seems like it's allowed. So 5 is allowed to go here. I think then so is 6 and so is 7. If this can be 5, 6, or 7. And what that's going to make this is 7, 8, or 9. And I think that's all allowed. This is now going to be a red cell. But we have this. In this region, we are allowed to use 4 low numbers. We're allowed to use the numbers 1, 2, 3, and 4. These are our yellow cells. But we know where 3 of them go. We know along the line there's going to be an oscillating pattern, which means one of these is going to be a red and one of them is going to be a yellow. But that's going to exhaust all of our yellows. So you guys must be the remaining red cells. You must be, you're not allowed to be a 9. You're only allowed to be 6, 7, or 8. But there's some problems with that. For example, you're not allowed to be a 6, and you're not allowed to be a 7. So now you can be 7 or 8. You can be 6 or 8. You can be 7, 8, or 9. Yep. And now we're going to have a low number and a high number on this line. That low number, are we able to do anything about that low number? That low number is definitely a 2 or a 3. Because that is the remaining number that is missing. I wonder what happens. I don't know. I don't know what happens, but I want to continue to click around and explore. We are almost 16 minutes into the puzzle, and I feel pretty good about the progress so far. But let's see. Neither of you on this arrow are allowed to be 1s. And what that means is that you can't be a 6. To get to 6, we would need to take 3 and add it to 1 and 2. That's the only way of getting 6. So you're not allowed to be a 6. But can you be a 7? To get to 7, these two would need to add to 4, and we would only be able to use 1 and 3 for that. Again, we can't have a 1 on this line. You're not allowed to contain a 1. You're not allowed to add to 7. That's the end of the story there. But what that means is that you need to be a 9, and now neither of you are allowed to be a 9. And if neither of you are allowed to be a 9, and we're missing one high number in this region, that remaining high number is going to be an 8. And it's going to live somewhere. That 8 can't go here, by the way. So we need an 8 in this region. That 8 can't go on the line. It can't go on the line because these two numbers need to sum to this number. What would that need to be? It would need to be 8 and 1 to make 9, but there's already a 1 in this row. That means the 8 definitely goes in one of these two cells. But the thing about that is that means this can't be an 8. You must be a 6. Definitely. You must be a 6. And now you can be a 7 or 8. But one of you two is going to need to be an 8. And if one of you two is going to need to be an 8, then this must be a low number. This must be a low number because we need what? We would have exhausted all of the high numbers in this row. If the 8 goes over here, you must be a low number. That's yellow. So you're yellow, and now so are you. And you two are our last remaining red cells in this region and along this line. Nice. If you're a low number and you're in this region, the only low numbers that you're allowed to be are 2 and 3. And if you were a high number, you are only allowed to be 7, 8, or 9. You must be a 7, 8, or 9. One is going to force the other to be something. If this is a 3, then this can't be a 7, for example. But this looks good. You need to be a low number. You need to be 1, 2, 3, or 4. You can't be a 1, but I bet you also can't be a 4. If you were a 4, then this would need to be a 9. That would cause a conflict, so you can't be a 4. And now can you be a 3? If you were a 3, you would need to be an 8, which would mean you would need to be a 7, which would mean you would need to be a 2, which would all be fine. I guess because these two are different numbers, if this was a 2, this needs to be a 3. If this is a 3, this needs to be a 2. That means that these two are the same number. I don't know if that's actually going to be helpful. Let's see. I'm brooding in silence as I figure this out. If you're... Well, we can repeat some things. You need to be a high number. That's going to be difficult with this arrow. Huh. You're a high number, but you're not allowed to be a 9 because there's a 9 in this column. You could be a 6, 7, or 8. You can't be a 6 because the minimum that this could be is a 2. So you can't be a 6. You can only be 7 or 8. And then that's going to make it difficult to sum to anything up here. If you were a 7, we could have a 1 or a 2 to get 9. Or 8, excuse me. You're only allowed to be an 8 or a 9, but you're definitely now a high number, red. And by the way, now you're definitely a low number. In fact, you're only allowed to be the numbers 1 and 2. But you can't be a 1. There's already a 1 in this region. You're definitely a 2. For you to be a 2, you would need to be a 7. For you to be a 7, you would need to be a 2. By the way, this creates a 9. Now you need to be a 3. I can use the keyboard for this. You need to be a 2. I was thinking I'd use the keyboard, but the train didn't really continue very much. I guess you're not allowed to be a 7, and it's just coincidental that that would mean that you're also not allowed to be a 9. You must be a 4, and if you to sum to 6, then I guess it's possible for this to still be an 8 or a 9, if this is a 2 or a 3. In this row, we're missing a 5. That 5 can't go on any of the colored cells. It can't go on this green line. You must be a 5, and now we're missing a low number. That low number needs to go here. You're going to be yellow. You also need to either be a 2 or a 3. So you're definitely a 2 or a 3 because of how this row works. Now, here we're missing a 1 and an 8. These are the remaining numbers. But if you're a 2 or a 3 and you're a 5, then you can only be a 7 or an 8. Red for a high number. You're definitely a 7 or an 8. We're really running out of spots for 5s to go in this region. 5 can't go here, it can't go on the green line. That means either a 5 goes here and we're going to get 7, or a 5 is going to go here. That would make this a 6 and we're going to get 8. Interesting. I guess now you need to be a 5, 6 because of how this column works. You need to be a high number. You're not allowed to be 6 or 8. You can only be 7 or 9. You need to be a high number. You're not allowed to be 8 or 9. You can only be 6 or 7. But 6 is allowed with the 2 1s. That's allowed. Did we figure anything out about this? I don't think we did. We need to make these sum to 6. They can't be 2 3s. They can't be a 5 and a 1. They need to be a 2 and a 4. In order for this to be a 2 and a 4, you need to be a 2. You need to be a 4. By the way, you're both yellow. And that fills that up. I wonder what's going to happen down here with this arrow. Because we can't have a 1, 2, or 4. It's not possible to put a 5 and a 6 here. A 3 must go in one of these two. One of you two must be a 3 just to allow any possibility here. But if you're a 3, then you could pair with a 5 to make 8 or a 6 to make 9. You can't be a 9. You need to be 3 and 5. You must be 3 and 5. Now you are 8. If you're 3 and 5, then you need to be a 6. Excuse me, you need to be a 6, which is a red number. Shouldn't need to fill that in. Now you're a 5. Remove the color. The colors are going to get in the way, so let's just stop that for now. But you're 7, you sum to 7, that means you are 7, that means you are 8, that means you are 9. So we now know these two boxes are filled. You need to be a 6, and we do get the 6 1 1 scenario. That's good. You're definitely a 3 and a 5. You are a 7 or a 9. You also must now be a 7 or a 9. I wonder where we're going to go from here. I guess in this column we're missing 2 digits. What are they? I bet what's going to happen is that this green line and the colors, which we didn't fill in, are going to expose this one pretty quickly. But here are our last 2 high numbers, which means these must be low numbers. You must be the numbers 3 and 4. If this was a 4, this would need to be a 9. And I don't see any problem with that. If this was a 3, this would need to be an 8 or a 9. And I don't really see any problem with that either. But we know that this needs to be an 8 or a 9. And if these two make 8 or 9, there's two cells that both are filled with 8 and 9. There's one digit missing for this column at 6. You must be a 6. Nice. All right, we've got low number, high number. This is going to be a low number. It's only allowed to be a 2 or a 3 because of this column. You must be a 2 or a 3. And now this must be a high number. It must be a high number that sees, I guess these are allowed to be 2s, right? So this could be, this one here could be a 7, an 8, or a 9. Let me put the colors in, just cause. I guess you're also. We have this. This is, yeah, this is going to be a high number. In this column, I don't know if I want to do that column. I guess we need a 5 in this row. That 5 can't go here because of this 5. It needs to go in one of these two. Can't go here because of this 5. It needs to go here. You must be a 5. And now in this region we need a 5. It can't go here or here. This must be a 5. And now we're really running out of 5s to fill in. But we haven't run out fast enough for that to be useful. I don't see where the last 5 goes. Are there any other digits that are close to being filled in completely? It looks like 8 is not going to be so much help. 7, it looks like 7 is not going to be so much help. 6, I guess we have a lot of 6s. This region of 6 needs to go here or here. Well, we know where the 1, 2, 3, and 4 go. We know where the 5 goes. These need to be the remaining digits, which are 6 and 7. And there's no conflict. Both of you are red. Now in this row, that means that these two need to be the remaining low numbers. These need to be 3 and 4, but we know which one can't be 4. You must be a 3, and you must be a 4. You're both low numbers. We're missing a 1. That 1 is going to go here someplace. I don't think that's the place to start. What are we missing maybe in this column? How about this? In this row, there's only one place for a 6. It's you. You must be a 6. And now that means that you must be a 7. Now that means that you must be a 9 and you must be a 7. Excuse me, you must be a 7. So we know that. Now this is 7, 8. This is 7, 8, or 9. Okay, so this all works. These two are paired. These two are paired. But I feel pretty good. We're 28 minutes into the puzzle. Hopefully we wrap this up soon. What are the two remaining digits for these two cells? Looks like we're missing a 3 and a 7. And this one can't be a 7. So you must be a 3. Now you must be a 7. We need a 7 in this region. That 7's going to need to go up here. And that's pretty much all of our 7s. There's going to be one here and one here that we have to remember to find. But that's all of the 7s for the most part. I wish there was something else in this row that we could use or something, but I don't see one. We need a 1 in this region. What are we missing in this region? We're missing a 5. That 5 needs to go here someplace. One of you needs to be a 5. Let's just fill them all in. One of you must be a 5. In fact, it can't be you. One of the outside needs to be a 5. We're going to need a 1. That 1 must go in one of these cells. We're going to need a 6. That 6 must go in one of... 6 can only go here, actually. You must be a 6. And then we're missing one more number, which is an 8. And that 8... Are there more 8s that I'm not seeing? There aren't. That 8 can either go here or here. So we have a little triangle of numbers there that are going to be, oh geez, what did I just do? 6 is trying to make you red. A little triangle there of numbers that are going to be annoying, I think. You're 3 and 4. What else are we missing? Well, we can almost figure it out. I wonder if... I don't see anything that would be prevented. So it's not possible to put a 7 in either of these rows, which means a 7 can't go here. It's not possible to put a 6. I guess in here we're going to need some things. I don't know. I don't know if that's the right one. In here we're missing a 6. That 6 needs to go either here or here. One of you must be a 6. We're also missing a 9. That mine must go here or here. We are also missing a 2. That 2 can go in any of you. And we're also missing a 4. That 4 can also go in any of you. That's what it looks like down there. Forget that. Is there something we can do with this line? Is there something I'm not seeing elsewhere? If this was an 8, these would both need to be 3s. No, excuse me. This could be a 3 and this could be a 2. That would be allowed. Now there's a 3 and a 5 here to add to 8. But I'm at the very end and I just don't see it yet. I wonder what I should do. I wonder what is it that I am missing. We need a 1 up here. That 1 could go anywhere. We need a 2 and a 3 up here. They can pretty much go anywhere, but importantly, they can also go here. So in these 5 cells that we're missing a 1, 2, but these are also unknown, so I don't think that's going to be very helpful. There just must be something that I'm missing with the numbers, I bet. Kind of bet. Okay. In this column, we're missing a 1 and a 5, definitely. That 1 can't go here. So you can be a 5, and you could be a 1 or a 5, but there is another number that we are missing in this column, and that number is 2. The 2 can't go up here. That 2 can go down here. One of you two must be a 2. In this column, we're definitely missing at least a 1 and an 8. You can be an 8, or you can be a 1 and an 8. Ah, you can't be an 8. So I guess this is how that looks. And then we're missing another number, which is a 3. That 3 can either go here or here. And now in this column, we're missing some numbers. We're missing, let's see, at least a 5 and an 8. That 8 can't go here, so you could be a 5, and you can be a 5 or an 8. And then the last number that we're missing is 4. You guys can be 4s. And it looks like this. Oh, geez. Is there some interplay between the 3, 5 here and the 3 and the 5 in here? I don't think so. At least not one that I see. It could either, the answer could either be hiding in this last region, which is a possibility. I guess we need a 3 in this someplace. That 3 can't go here. Or it's hiding in this line, or it's hiding in this sum. You two sum to 6. So you could be a 2, and this would force you to be an 8. That would also force you to be a 3, and you to be a 3 at the same time. That would force you to be a 9. This is interesting. I wonder if one of them just has a contradiction, and we just need to figure out what that is. If you're a 3, then what happens? You need to be an 8, but then you need to be a 2, and that makes you an 8. But you can't be an 8, so you can't be a 3. That's the deal. So you can't be a 3, you must be a 2, now you must be a 7, now you must be a 3. The sum of these is 9. This needs to be a 2, so that this can be 8, and this green line holds. Now you need to be an 8, and you need to be a 5. Now you need to be a 1, and you need to be an 8. Down here, this would need to be a 3, this would need to be a 1, this would need to be a 4, and this would need to be an 8. Now we have 2 and a 5 here. But fixing that is not going to be a big concern because there are other things that are filled in, like these, like this one, like this one, like this one. 1, 8, 6, 7, 4, 6, geez. And now we can do the last square. The numbers that are missing in this region are 1, which we know where it goes, 3, which we almost know where it goes, 4, and then 9, but we're going to be able to place things. So you need to be a 1, we know that. You need to be a 9, we know that. Now you are going to be 3 and 4, you're going to be 3 and 4, but you can't be a 4 because of this 8. So you need to be a 3, you need to be a 4, you need to be a 4, you need to be a 3, and we solved the puzzle in just under 36 minutes. We were the 320th solver. I wonder, I don't remember, but maybe when we started we were 319 and maybe nobody solved it in that intro, but I don't know, maybe it was many people. Anyway, if you got this far in the video, thank you for watching, and I hope to do another puzzle with you soon on this channel. I really enjoy these, as well as, I think this channel has a pretty diverse puzzle content, but this was a puzzle through Sudoku Pad. I tend to find these on a site called DutchLogicMasters.com, and I'll include a link down below where you can play it yourself. So thank you for watching, and I hope to see you in the next video. Have a great rest of your night.